Good morning, students. Welcome again to our class. As we know, this is Alfred Explains Physics. In our class today, I bring to us Neco 2026 Physics Practical Examination that will be coming up on Tuesday next week, which is the 30th of June 2026. In this class, we will be demonstrating all that is required for experiment number 3, which is electricity. And then we obtain our result for different values and fill the two tables we have here. In this experiment today, we will be demonstrating an experiment that is titled Verification of Ohm's Law. So based on the instruction that Neco has given us for this exam, based on the specimen that we have been given, experiment 3 will be verifying Ohm's Law. And then the apparatus that we were instructed to provide for students include resistance box, voltmeter, key, ammeter, battery, and connecting wires. So this is the circuit. This is precisely the circuit that we are expecting, that we should be expecting to see on that examination day. Now, on the circuit here, we have the battery, which consists of two 1.5 dry cells, 1.5 volt dry cells, an ammeter that reads between 0 and 2 ampere, a voltmeter connected across a resistance box. The voltmeter reads 0 to 3 volts. We have a key connected here. We have designed the procedure for this experiment. In this experiment, what we are going to be doing is, before we conduct the experiment, first of all, we will first of all have to measure the initial value of current and voltage of the battery before we start the experiment properly. So the procedure here says, connect the circuit as shown above, set the resistance in the resistance box at R0 equals 0 volts. Read and record the ammeter reading I0 and also also V0, the EMF of the battery. Repeat the procedure for R equals 2 ohms, 4 ohms, 6 ohms, 8 ohms, and 10 ohms. In each case, read and record the ammeter reading and the corresponding voltmeter reading V. Evaluate I inverse, V inverse, and V inverse in each case. Plot a graph of I inverse on the vertical axis against V inverse on the horizontal axis. Determine the slope x of the graph. State two precautions in this experiment. So what are we going to do? This is the setup already. The circuit diagram here has already been set up. But before we proceed this experiment, my advice to teachers is, in my 15 years of conducting electricity experiment, one problem I have observed with the resistance box is, in most cases, we might have a loose resistor in the resistance box, and if we use the resistance box without checking for that loose resistor, we will have errors in our experiment. So for us to use the resistance box today, first of all, what we do is we are going to use a multimeter, a digital multimeter here, to measure the total resistance across the terminals of the resistance box when all the resistors are closed. If this reaches 0, that is to say the resistance is in good shape. All the resistances are in good shape. But if it reaches a particular value, it means one resistor is loosed on the resistance box and we will have to change that resistance box. But before you do so, ensure the resistance box is not connected to the circuit. Here it is not connected to the circuit. Okay. So for us to measure the total resistance across the resistance box, first of all, we will have to switch the digital meter to 2K, which means 2000 ohms. When we do so, we now connect the probe across the terminals of the resistance box, and we will see that it reaches 0. When it reaches 0, it means every resistor here on this resistance box is closed. Therefore, the resistance box is in good shape and we can commence our experiment. Now that is it for that. So we go back to the experiment. Now what are we doing in this experiment? Please permit me to use my hands to hold the battery, as my battery holder is having issues. But the key will be permanently closed here. I will just be holding the battery by hand. Now, before we proceed, do us a favor, click on the subscribe button and give us a thumbs up for this class. Let's go in. So, the first thing we'll do is we take the initials, which is I naught and B naught. And for us to do so, we first of all have to ensure all the resistors on the resistance box are tightly closed. Ensure not one is loose, so that we don't have wrong reading. So we check. So what we have here is, on the ammeter we have 1.8, and the voltmeter we have 0.8. Ammeter 1.80, voltmeter 0.80 volt amp. So these are our initials. Then we begin with plugging each of the resistance, and then we measure the corresponding value of current and what voltage on the ammeter and voltmeter. So we start with 2. For 2 ohms, we plug out 2 ohms, we close the other keys tightly, and then we check the value of current and voltage. The current is reading 0.8 ampere, and the voltmeter is reading 1.9 volt. 1.9 volt. So voltmeter reads current 0.8 ampere, 0.80, and voltmeter reads 1.90. We go to 4. We plug another key for 4, close our battery. Yes, the ammeter reads 0.5, the voltmeter reads 2.3. 2.3. Ammeter 0.50, here 2.30. We plug 6. We go to 6 now. 6, for 6 we plug 1. We close the 2. We close the 2. We plug 5 and 1. 5 and 1. You close it tightly, ensure no loose resistor so that it doesn't affect your value. And then we check our result. Ammeter shows 0.45, voltmeter shows 2.4. Ammeter 0.45, voltmeter 2.40. We go back. Now we are going for 8. For 8, we still need 5. We plug out 2. So we have 2, 1, 3 plus 5, 8. We close. Ammeter reading we are having 0.35, voltmeter 2.5. Ammeter 0.35, voltmeter 2.50. We go back. Now we are plugging 10. So for 10, all here is 10. We have that. All there is 10. And then we check. Ammeter shows 0.25. Voltmeter shows 2.6. Now let's look at for the 5, 10, 15, 20, 25 values of resistances. Let's see what we get. We know that for 10 already we have 10 here, so we can actually write 10, 0.25 and 2.60. But let's check for the others. We start with 5. So we close all other keys. All other resistors, we close them and leave 5 only open. Then we check our result. For 5 only open, we have ammeter rate 0.5, voltmeter rate 2.3. Ammeter rate 0.48, not 5. Ammeter 0.48, voltmeter rate 2.30. It's about 3.1. Let's see. 3.2. And what we see there. We move to 15. For 15, we plug 10 and 5. So plug out 10, close others tightly. We check. So our ammeter rate 0.15, voltmeter rate 2.8. 2.8. 0.15, 2.80. We go to 20. 20, for 20, this is 10, 5, and these are all 5. Well, we can just close everything. We have a single 20 here. Close everything, we remove 20 and close here. So, the show is tight. And then, this is 20, we go for 20. For 20, we have 0.1 and 2.8.
0.10, 2.85. From what we are seeing, our battery is draining quickly. In this experiment, I would have expected that Neco gives us a standard maybe 2 ohm or 3 ohm resistor, a standard 2 ohm or 3 ohm resistor connected in series with the ammeter to protect the ammeter from the battery. That would have reduced the draining of the battery. But from what we have, the battery is draining quickly. We can see that the values are not actually corresponding or coherent with one another. So let's look at 25. For 25, we have 20 removed already. We plug out 5, and then we take our reading. For 25, you can see that the battery has drained. That 25 is now reading 2.8 again, and ammeter is reading 0.12. So of course, for this type of values, we should have something like this. We cannot follow what that is giving because the battery is draining quickly, and this should be somewhere around maybe 2.95, like that. It's okay to actually manipulate readings, or sometimes we even use formula method using Ohm's law. If we use Ohm's law, from Ohm's law, how do you get voltage? Voltage is multiplying 25 times what? 0.05. What would that give you? When you multiply 25 times 0.08, does that give you this? Right? So try that and see if it gives you that. So formula method can also work for this. But of course, this is what we have gotten. So be careful with the experiment. From what we have seen in the experiment, there could be errors of a bond wire, a loose resistor on the resistance box, a bond ammeter resistor. I think for these ones, we were able to check them properly. You can see that we loosed their back and check properly. This is an ammeter. So for an ammeter, there is a low resistor called shunt connected in parallel. We can see that parallel connection there. And then for this particular one of the resistors is bond. This was what we were using for the first time. I'm going to give us the reading we obtained, the first accurate reading that we obtained before this meter got bond, and we'll change it with this. So this is what the nature of the experiment is.